Okay, so the last topic we want to take a look at is the concept of a gear. So let's think about a bike. So for when you have a bike, something like a 10 speed, so you'll have, or we'll say just a 5 speed for now. So you have one big gear in front, and then in back, you have a bunch of other gears. Right, 2, 3. We'll make it a 3 speed for now, just because the same principle applies. Okay. So there's going to be a chain that's going to connect, say initially we're on the smaller gear to the larger gear. Okay? So the bigger gear is going to have radius R1. The smaller gear is going to have radius R2. Okay. So now as these two spin, right, this chain is spinning around. So this is going to tell us something about the rotation of the larger gear and the smaller gear. So I want you to pause the video for a second and see if you can figure out what that is. Okay, so initially you might think that, well, maybe it's the angular velocity. Maybe omega 1 is equal to omega 2. But that's not really right, and we'll see why. So let's imagine a point on this chain. Okay, so when this starts spinning, it's going to be moving with the velocity v. So sometime later, that same point's going to be here. If the chain's still spinning at the same rate, it's still going to be moving with the velocity v. It's going to get to this point on this one, it's going to be moving with the velocity v. Here, it's going to have a velocity v. And over here, it'll still have a velocity v. So it'll always have the same velocity moving around, right? Because this is a chain. It's all moving together. So that means that the velocity is constant. So omega 1 R1 is equal to omega 2 R2, right? So this tells us that the angular velocity of the back gear is going to be the ratio of the radius of the front gear over the radius of the second times omega 1. Okay? So now let's see what happens when we go to a bigger gear. So if we increase R2, in other words, we shift up to the next gear, we see that now this ratio is smaller. So in other words, initially omega 2 in this case is spinning much faster than the larger disk. But now when we've moved to the next gear, it's not going to be spinning as much faster. And then if we go even higher to the next gear, it's spinning even slower. And then if we added one more gear, say that's the same exact size as the one in front, now we would see that in this case we actually would have both their angular velocities and their linear velocities would be equal. Okay, so that's the main principle behind gears, is just that the velocity of any point on the outside of either of them is going to be the same, because the speed of the gear moving around is going to be the same. And so you'll see a bunch of problems like this in Halliday-Resnick-Walker, and you'll almost definitely get a problem related to this somehow on the exams that you're taking.